Switching from IPv4 to IPv6 isn't an overnight affair. Imagine convincing an entire city to drive on the opposite side of the road all at once. Utter chaos, right? We're talking about billions of devices and services still stuck on IPv4. So to make this transition smoother, we have three key mechanisms. First, there's dual stack, which is like being bilingual. Devices can speak both IPv4 and IPv6 at the same time. Tunneling is sort of like sending an IPv6 letter inside an IPv4 envelope. And then there's translation, which works like a translator at a multilingual meeting, converting between the two protocols completely. Knowing when and how to use each of these methods is something you'll need for the CCNA exam. Think of dual stack like the Swiss Army knife of networking. It lets every device operate with both IPv4 and IPv6 simultaneously. And just like deciding between tea or coffee in the morning, the application gets to choose which one to use. Now, when it comes to tunneling, imagine sending a letter inside a bigger envelope. It allows IPv6 packets to hitch a ride inside IPv4, so they can travel through regions where only IPv4 works. You've got some options here like 6-to-4, ISATAP, and GRE tunnels to pull off this trick. And then there's NAT64 paired with DNS64, which is like having a translator at a big international conference. This setup lets an IPv6-only client chat with an IPv4-only server by converting addresses and rewriting packets through a NAT64 gateway. Feels a bit like magic, doesn't it? But it's perfect for connecting the old world with the new. Imagine you're on two tropical islands that only speak IPv6, surrounded by a sea of IPv4. To have a conversation between the islands, you need a bridge, and that's what a tunnel is for. At each end of this tunnel, you've got routers that can speak both languages, like dual citizens with passports for both IPv4 and IPv6. When an IPv6 packet wants to make its way across the IPv4 sea, it hops inside an IPv4 envelope at the tunnel's entrance. Then the IPv4 network plays the role of an efficient postal service, delivering it as if it were just another piece of mail. Once it arrives at the other island, the envelope is opened, and the IPv6 packet is free to continue its journey to its final spot. Let's dive into 4 transition traps that might catch you off guard. First, dual stack isn't a tunnel. It's like ordering both pizza and sushi for dinner. You get to enjoy both separately, no mixing or blending, no encapsulation happening here. Next, 6-to-4 tunneling uses the 2002/16 prefix. Think of it like a specific street sign for your neighborhood, while ISATAP sticks to its own format with FE80/64. Moving on, NAT64 and DNS64 work together like a superhero team for name-based lookups. DNS64 creates those AAA records you need for destinations that are still clinging to IPv4 only. And finally, remember that tunneling comes with overhead. It's like bringing an extra suitcase on a trip. The outer IPv4 header is 20 bytes, which means a smaller effective MTU and potential fragmentation. Keep an eye out for that. Choosing the right network configuration is like picking the right utensil at a dinner party. Dual stack is your trusty knife and fork when your devices and network are ready to feast on IPv6, but still need to handle a bit of IPv4 on the side. Tunneling is like using a tunnel to drive between IPv6 islands when you're surrounded by a vast IPv4 ocean, a bridge to connect those separate worlds. And when you need a translator between languages, that's where NAT64 steps in. It's perfect for those IPv6-only clients trying to chat with those stubborn, old-school IPv4 services that just won't adapt to new lingo. And that's the scoop on transitioning from IPv4 to IPv6 using dual stack, tunneling, and NAT64 translation. Swing by Courseiva.com to tackle some CCNA practice questions. You've got this. Keep going.